Essentially, when we talk about epistasis, we are talking about gene interactions. This, of course, means that epistasis has to occur when there are more than one gene, so two or more genes contribute to the same phenotype. This is often described as when one gene masks or modifies the phenotype of another gene. An easy way to visualize this relationship is by imagining a game of tug-of-war. Person A is gene A, person B is gene B, and the rope between them is epistasis. Realistically, however, these interactions would look more like a web. Now let's examine how multiple different genotypes could lead to the same phenotype in epistasis. In this first example, gene A will be epistatic on gene B in the case of recessive epistasis. We will first assess the phenotypic ratio of F2 individuals formed by crossing two double heterozygous aliens. The following expectations will be used. Uppercase A and uppercase B are dominant to lowercase a and b. A and B genes exist on separate loci. B alone acts as a regular Mendelian gene, where uppercase B is dominant, homozygous little b is recessive. For this first example, let's use a cross between fictional aliens that have two genes which contribute to antenna growth. Big B encodes growth of 3 antennae in these aliens, and little b results in 1 antenna. The big B allele encodes a hypothetical enzyme which promotes antenna growth from 1 to 3. The B allele encodes an inactive form that cannot produce more than 1 antenna. So how can we have an alien with no antennas? The second gene, big A, is epistatic on big B. It encodes a protein necessary for the growth of an antenna. If big A is not present, the alien will not be able to grow an antenna. So let's consider the classes produced as a result of this cross. If big A and big B are present, the alien will have 3 antennae. If big A is present but not a big B, the alien will only have 1 antenna. If big A is absent, no antenna is formed. Typically, for a normal dihybrid cross, you would expect a 9:3 to 3:1 phenotypic ratio, but due to the interaction of genes laid out in this pathway, we end up with a ratio of 9:3:4. This is an example of recessive epistasis because a recessive allele of one gene masks the effect of either allele of the second gene. We can apply similar logic to a different cross between aliens of the following genotypes. The only difference would be the initial ratio of genotypes derived from a Punnett square. Here we only have 2 F2 genotypes of big A, big B, and little a, big B. Following the same pathway logic from the first example, the phenotypic outcome of this cross will result in 8 aliens with 3 antennas and 8 aliens with no antennas.